In this lecture, we're going to talk about C++ strings, which we've been using all semester. So part of this lecture will be a review, but you're going to learn some new features about C++ strings as well. Now, one thing to remember is that strings are not a built-in data type in C++. Instead, they are a class. And at the beginning of the semester, we told you you should really use the include statement to include strings in your program. Now, I know many of you have probably gotten lax on that because our compiler includes strings when you include IOstring. But if you really want it to be safe and make sure that your code would compile with different C++ compilers, you would put #include string at the top of each program. And if you remember, the include string, what it does is string is a library, and it is including the string library. String library has a declaration of the string class plus a definition of the functions used by the string class. And it's a perfect example of where you've actually been using a string without knowing how it's implemented. In fact, we're not going to tell you how it's implemented. Well, I'll tell you that it's implemented using character arrays, but you'll learn more about that if you go into more advanced CS classes. But you've been using it and just using functions like comparison functions, like the assignment operator, without even realizing that that's what you were doing. So you're used to the syntax now. You declare it by just saying a variable name of type string, so string variable name. So an example, I've declared the variable city to be a string, and that creates a string object named city. And I can initialize my strings. You've probably been doing that a lot this semester just by setting the string when you declare it equal to some string. Now that you've learned about constructors, it's also possible to initialize a string by calling this constructor and passing the string as a parameter. My preference is this first one, to do string assignment. I think it's more natural and easy to read, but the second technique works as well. String assignment, you've been doing that again all semester, and you can assign literals to strings. So here, address equals 1678 Cardiff Road. So after I declared address and address copy, question marks, because remember, if we don't initialize them, we're not sure what they are. But after I assign the constant 1678 to Cardiff Road, that's what's, or to address, that's what's in address. And then when I assign address to address copy, it actually physically copies that string, which was in address, to address copy. So when I'm done, there's two separate copies of 1678 Cardiff Road, one in address and one in address copy. And then if I assign, say, 1000 Rockwood Lane to address, it changes address. See, it's 1000 Rockwood Lane, but it did not change the value of address copy, which remains 1678 Cardiff Road. And you can do string concatenation using the plus operator. So when you do that, when you use the plus operator, that takes two strings, concatenates them together, and returns the result as a string. So as an example here, I've assigned 1678 to string 1 and Cardiff Road to string 2. And then I combine them by saying S1 plus a blank. So this right here is a blank space, or a string containing the blank space, and plus S2. So what I'm doing is concatenating a blank space to the end of S1, which was 1678, and then I'm concatenating S2, which is Cardiff Road, to the string that resulted from S1 plus the blank space. So that whole thing gets assigned to S3, and I end up with 1678 Cardiff Road as a single string, and there's a blank space right here between the 1678 and Cardiff Road. So plus, when used with strings, actually concatenates two strings together. And all the relational operators work as you might expect with strings. So you can compare two strings for equality using the double equal sign. You can check to see if two strings are in alphabetical order using less than. So here I'm asking if S2 precedes S1 in alphabetical order by checking to see if S2 is less than S1. And this works with all the comparison operators. So down here, just showing you some examples. Brad, so this column right here is showing you what the result is if I do the comparison S1 less than S2. This next one shows what happens if I ask if S1 is greater than S2, and the third one shows what happens if I ask if S1 is equal to S2. So clearly Brad is equal to Brad, string 1 is equal to string 2, so that should give me a true, but obviously false for the other two. When I compare Brad with Yifan, Brad occurs before Yifan in alphabetical order, that is, it's less than Yifan, so now S1 is less than S2, that returns true, and the other two comparisons return false. Then if I compare Frank and Bill, well, Frank is actually greater than Bill in alphabetical order. F occurs after B. So the only one here that's true is S1 greater than S2. So Frank is greater than Bill. If you're wondering how it does the comparisons, it does it character by character. So in each of these cases, well, for example, with Brad, it compares the first characters, they're equal. Then it compares the second characters and they're equal, and so on. If I had, let's say if instead of Frank and Bill, I had Brad, the outcome would have been the same, which is Brad is greater than Bill. But in this case, what would have happened, it would have compared the B in Brad with the B in Bill, and those are equal. So then it would have gone to the second letter, which is R, and R is greater than I, and hence it returns true for S1 greater than S2. And you may remember we kind of have alluded to the fact that in memory, the way characters are actually represented are as numeric codes between 0 and 255. So in memory, each character, like the B, the R, the A, and the D, is actually stored as an integer. For example, perhaps A might be 80, B might be 81, C might be 82, and so on. And the integer codes are set up so that A is a smaller integer than B, which is a smaller integer than C, and thus you get your alphabetical order. Okay, as you've seen throughout the semester, string IO works just fine with the input and output operators, and you did experience perhaps some frustration in that when you do the input operator, it can only read one word at a time, and it stops as soon as it hits any white space. So for example, if my input is Brad Vanderzanden and there's spaces between each of these three words, then actually this statement up here, cin, and reads a word into string name, actually all that gets read into string name is Brad, not Brad Vanderzanden, because the reading stops at this blank space. And if you remember, we used the get function that was associated with cin if we wanted to be able to read spaces. So if we wanted to actually be able to accumulate, say, the entire line, you may remember from one of your labs that it went something like for I equals 0, I less than, well, actually we started out by doing a get, so it was something like cin.get and some variable like char c. Whoops, that's not what we want. Well, we don't want it converting it, so we'll give it another. We'll say letter. Okay, and then we were doing concatenation. So we were doing something like saying while cn.get is not equal to the new line character, and then we would concatenate our name. So we'd say plus equals a letter. And the plus operator does just fine with concatenating chars. Letter here is a char. So it does fine with concatenating a letter to the name. So just a little review from chapter 6 when we were talking about the get function. Okay, so strings, now we're going to start, this is up to now been some review with strings. Now we're going to get into some new stuff with strings. So first of all, strings can be treated like arrays. So here I've assigned the value drawer to word. And if you look at this in reverse, you can see that drawer in reverse is actually reward, R-E-W-A-R-D. So I can actually get a program to print it in reverse by treating word as though it's an array. And the length function is going to return the length of word. And remember that with arrays, indexing goes from 0 to the length of the array minus 1. So if we're going to print reward in reverse, we actually need to start with the last character, which is a D. And based on our array subscripting, we know that the last character is going to be at the length of the word minus 1, hence our initialization here for I. Then we want to continue until I is negative. That is, while I is greater than or equal to 0, we still want to print characters. And after each character is printed, we're going to decrement our loop subscript by 1. And then in our loop body, we simply output the current character. We get at that current character by treating word as an array and indexing into the ith location. So as you see down here, when you put I in index or array notation as an index, then it returns the character at that position, and length returns the length of the string. So it's very handy to be able to treat strings like arrays with each element in the string being a char. So sometimes we want to be a bit safer. It turns out that treating a word like an array and using just normal array indexing, if we index past the end of the word, remember that indexing past the end of an array can be dangerous and that C++ doesn't normally catch it. But because strings are classes, they actually were able to define a function called @, which you could use in place of array indexing. And it's a safe version because if you try to index past the end of the string, it will actually print an error message. Here I've just shown you an example where I print out the first character in the array with adder. Adder is my string dot @0, and it's printing the first character. Okay, so I could have done it as well. I could have said @0, and that would have also worked. But for example, if this was an empty string, this would give me a nonsensical result with array indexing. But if I said @0 and I had an empty string, now I would actually get a runtime error message telling me that this string, or that I tried to index past the end of the string. It's up to you what you use in your programs. I must be honest, I use array indexing rather than the @. I find it to be, it creates code that's, I think, easier to read, and I think if you're careful, then you won't be writing past the end or reading past the end of. Okay, so now we're going to move on to another fancy thing that you can do with strings. And you're going to see it involves something called string streams. So here's my problem. Suppose that I have some input, some exam scores for students in a course. These are Disney characters, and let's say I made the final exam optional. So Mickey Mouse thought that his score was just fine and chose not to take the final. Donald Duck and Winnie the Pooh took the final. So I want to read the exam scores for each student, and I want to print their average. So here's some possibility of what I could do and an example of how CN is going to fail. So I could try to, I know I always have a first and last name, so I use CN to read the first and last names. But then I'm not sure whether I have 2 or 3 final exams. So I could just optimistically try to read 3 scores into exam 1, exam 2, and final. But what's going to happen if there's only 2 scores? Well, what's going to happen is it's going to read Mickey into first name, it's going to read Mouse into last name, it's going to read 78 into exam 1, it's going to read 95 into exam 2, and then remember, C++ uses a stream model that ignores new lines, so it's going to try to read Donald into final. And that's not going to go down too well because Donald is not a number. And at this point, it turns out that the input operator would return fail. If we actually check the fail function for CN, we would find that the input operation failed. And now we'd actually be stuck. We haven't told you how you could continue in this situation. So we need to find a way that allows us to determine whether there's 2 or 3 exam scores. And ideally, if there were more than this, let's say that there was homework assignments, maybe some people did 5 and some people did 8 and some people did 10. We want to be able to have a way that handles an arbitrary number of scores. And what we really want to do, as you can see, is actually read a line at a time, because even though C++ uses stream I/O, in this case we really want it to do line-oriented I/O. We want to read a line, process all the scores on each line. Well, we can do that by calling a function called getline, which will read a full line of input. But then, once we have that full line of input, we need to find a way to break that line of input into the name and exam fields. And we'll do that using a new concept called string streams. We've already seen I/O streams and file streams. So this is the same idea, except it's going to be a string stream. So let's tackle getline first. Just said getline reads an entire line, and you pass in a stream variable as your first argument, so it can be either CN or it could be a file stream. And you also pass in the string that you want the line to be read into. So in this case, when we're done reading the line, it will be in the variable S, and same thing here. And actually, if we were doing these calls, it's done like here. This is actually kind of showing the parameters and their declarations. The actual use, here we declare a variable called line, called getline on CN, pass it the string line, and it reads a line from the console into line. And you could think about, how does getline declare the line parameter? It actually declares it as a reference parameter. So that's why when the function getline returns, our line variable has the line that was read. And if instead we had an IF stream, we could pass, in this case, from file as the first argument to getline. Again, pass our line variable as the second line or second argument, and when we're done, the next line has been read from file into line. Okay, so that took care of get lines. Now let's turn our attention to string streams. So string streams allow you to do a couple nice things. They allow you to extract fields from a string using the input operator. So you've used the input operator to read from files and from cin, and now we're going to also be able to read from a string. And that will be useful when we've embedded numbers in a string, like those exam scores you just saw. So back here, we had these exam scores, and we really want to be able to read them from a string into integers. So basically, after we read getline, if we were going to be reading into a variable named line, what we would have is Mickey Mouse 7895. And what we want is to be able to read Mickey into, say, first name, Mouse into last name, and then have some way of reading these numbers right here into ints. And streams are going to allow us to do just that. Okay. String streams. So they allow you to extract fields from a string using the input operator. And sometimes it turns out you don't want to print a formatted string to the console or to a file. Sometimes you actually want to create a formatted string in memory. And we'll show you an example in a moment where we would like to create a formatted string for time. And we can do that with the output operator. So we're going to find out that string streams behave just like cin and cout, except that they work on strings rather than the console. And that just like cin and cout, you can test them for EOF. So they have the EOF method, they have the fail method, they have the input and output operators. So if you're going to use string streams, you need to include them in your program. You do that with #include ststream because they're classes, just like IO streams and F streams are classes. Ststream is a class, so you're going to be including its library. That library defines the ststream classes, and there's two of them. There's input streams, or string streams, and ostring streams. And as you might guess, string stream stands for input string stream. And here I've declared a variable called buffer. They have a few handy methods. So we have str string, and that will assign a string to this string object, and that will then allow you to break it into fields. This clear method should be used when you want to reuse an string. So sometimes you're in a loop, and each loop iteration wants to reuse the string, put a new string into it. And you might think that you could just call string, pass it a new string, and it would work, but turns out it doesn't. You first have to call the clear method in order to, in effect, erase the previous string. Then you can call string, or str, to assign a new string. And finally, the input operator reads the next field from the string and converts it to an appropriate value. And again, it stops when it reaches a white space character. So here's our example again, where we are reading those exam scores for our students. So let's go back and take a look at the input again. It can be a first name, a last name, and then either 2 or 3 exam scores. So we're going to declare a exams array with 3 elements, although we may not fill it up. Only 2 elements may get filled. Here's our string stream and our first and last name and the line we're going to read. And these are some other variables, like we want it to compute the average, so we're going to have to keep a running sum. And we have to keep track how many exam scores we read. That's going to be kept in count. So we start, and we're just going to read one student, so we call getline, and we're reading from the console, so we pass it cin as the first parameter. We pass our line variable as the second parameter, so that will read a line from the console into our line variable. And actually, I did not need to redeclare my buffer here, so I'm going to get rid of this. And I just call str, assign the line to it. So now I'm ready to, I've basically, it's like, well, I've initialized it to line. So now I'm ready to break it up. And I start by reading the first and last names. And then notice my while loop, which I'm treating it as though I was reading to end a file. And because end of file will become true once I've exhausted all the fields in the string, it's exactly what I want. So while I'm able to read another exam score, I do so. Put it into the first available empty spot in the exams array. So initially count was initialized to 0. So the first one will go into 0. Then after we successfully read one, we increment the count. And we also keep a running sum of our scores. And at the end of the program, we print out the average as sum divided by count. And you notice we didn't actually use the exams array here, but one could imagine now using the exams array. For example, if I wanted to drop the minimum score, I could go through and subtract out the minimum score. I could find the minimum and max. I could sort it and then get the median out of it, which would be the middle element, all kinds of things. But the point is that I was using this stringstream to basically accurately extract our exam scores from that line, and it comfortably handled 2, 3, actually any number of exam scores. Notice there's no assumption here. I guess there's an assumption up here that exams, there's be no more than 3 of them. Of course, if I wasn't sure how many exams I was going to read, then I could simply change this. I could make it a vector of ints, right? And then I could read as many exams as I wanted. There would be no limit to the number of exams I might read. Okay, so you can also remember you can output formatted strings using an ostring stream. So that's an output string stream. And again, you declare a variable, and then you can write strings to that stream using the output character. And when you're done writing things into that string stream, you can extract the formatted string using this string method. So now the str method returns the formatted string. So with an string, it allowed you to initialize the buffer to a string. In an ostringstream, it allows you to remove the formatted string that you created. Not remove, but return it. So here's an example. Let's say that I want to take 3 integer variables, hours, minutes, and seconds, as parameters, and I want to create a string that's formatted with colons between them. So the format right here in hours appended to the end. So that's a perfect situation for doing an ostring stream. Notice I didn't say print it to the string to the console. I said create a string and return it. So my return value is a string, takes 3 integers as inputs, and now I'm going to have to convert these integers to string variables and store them in my formatted string. So I declare this variable called time to be an ostring stream, and now I can use the output operator to put hours, colon, minutes, another colon, seconds, and finally the string hours with a space before it, all into time, and finally I can get that string out by calling time.str. And when I return it, that gives me a nicely formatted string. So we have one more thing to cover. We've covered strings as arrays. We've covered getline, which allows you to read a line into a line from either a file or from the console into a string. And we've covered string streams. The input string streams let you break up a line of input into fields. And conversely, an output string stream allows you to actually create an in-memory version of a formatted string that you can then, say, manipulate in some further fashion. So the last thing we're going to talk about are some handy string manipulation functions that you have not yet seen. So sometimes you want to be able to extract a substring from a string. So there's a handy substring function that does that, and it takes a starting position and it returns length characters. So we had name dot substring position 4 length 3. Well, what that would print, if you do a little count here, Brad, the B starts at 0, R is 1, A is 2, D is 3, and the blank space is 4. So actually you would end up with a string that was a blank space VA. Okay, might not be what you wanted. Maybe you wanted to extract Brad, so I could say 0, 4. And that would extract the string Brad because it would start at location 0 and return the next 4 characters, which is Brad. So that's a handy thing for being able to extract substrings. In fact, we'll use it in an example shortly. The find function is handy for finding the index location at which a substring starts. And often it's just a single character that you'll be using, like a comma or a colon, because a lot of times you're using find to find a delimiter in a string, like a comma or a colon or a period, and then you want to extract the substring that occurs before that delimiter or after that delimiter. At any rate, it returns either an integer index if it finds that string, or a constant called string : in position, so right here, in POS, and you have to prefix it with string : so if it doesn't find the string, that's what you get. So for example, shouldn't have deleted that text string. So again, let's say I have string name equals Brad, Vander, actually let's not even do that, no spaces, Zanden, like that. And if I then say int location equals name.find and a colon, what will be placed into location is the value 4, because B starts at 0, R 1, A is 2, D is 3, so the colon is at 4, and it returns the first location. So then I could actually get first name. I could say first name equals name.substring starting at 0 and going to location. Okay, because location, it doesn't go to location, but location contains, since I started at 0, it contains actually the size of the substring I want, which is 4 characters in this case. Okay, now let's say I wanted to extract the last name, which is, let's just ignore, actually let's pretend now that this colon doesn't exist. So now we just want to extract what's after the colon. Okay, And we can do that by saying string last name equals name dot substring. And now we would start at location +1 because we want to start after the colon. In fact, if we give it just one argument to substring, it returns the rest of the string. So in this case, I just gave one argument and it returns the rest of the string. If you remember from our discussion of classes, we said that constructors could have multiple declarations. It turns out you can do the same thing with any member function. So there's one declaration for substring that takes two parameters, and it is a position and a length, and there's a second one that just takes a position and it returns the substring, the rest of the substring starting at whatever position you give it. Okay. Our third one here says, okay, we want to find this substring at string 1, but we want to start from location position. And why might you want to do that? Well, let's say that there was actually another colon here like I started with. So in this case, maybe it is middle name and last name. So now we want to extract middle name. And I know the screen just went to a darker color. I need to fix that. Just give me one moment here. So I'm using a program called Flux, so I need to disable it for another hour. Flux is a program that when the sun goes down, it darkens the screen a little bit, takes out some white light. Okay, so now we want to extract the first name, which we got. Now we want the middle name. So we actually want to get the end location for the middle name. Have int end location, and we're going to do name.find. We're going to again be looking for a colon, but now we want to look for the second colon, and so we want to pick up our search from location +1, and that will give us our location of our second colon. So now if we want to get our middle name, I'll call it middle name, we would start at location +1, and the number of characters in it is going to it's going to be end location minus location. Okay, so I always need to check this because we could be off by 1. So if we do some counting, we know that location was equal to 4. Okay, so then picking up the count at 4, we know that V is at 5, A is at 6, N is at 7, D is at 8, E is at 9, R is at 10. So the second colon is at 11. So we know that N location is equal to 11. We know that location is equal to 4. So 11 minus 4 gives us 7. And that looks like one too many because Vander is 6. So in fact, that does mean we need to subtract 1. And this is actually a good lesson for you in using concrete data to verify your assumptions rather than just thinking it's right. So I do this all the time. I've been programming for 30 years, but you need to check these things, and taking some concrete data and checking it is often a very good thing to do. So at any rate, this will extract the Vander and put it into middle name. Okay, so you've seen substring find and find restarting it at some position. Not restarting it, but starting it at some position. The last two allow you to insert new substrings into your string and to erase things from your substring. So let's say that I want it. Let's say my string was Brad Vander Zanden. And actually, I have a middle name. It's Tanner. So let's say I wanted to insert it after the first blank space. So I'm changing that now to finding the first blank space. And now I want to actually insert, my middle name, which is Tanner, into it. So I'm going to say name.insert, and we're going to start at location +1 because that's right after the blank space, and we're going to insert Tanner. And actually we need to insert another space after Tanner, or else Tanner would have a run-on with Vander. So right there we just inserted my middle name into the string. And finally, I could erase my name. Let's say I wanted to instead erase Brad. I just wanted the last name. Okay, so I want to get rid of the Brad. So again, now I still want to find that first space, but now I want to in effect erase up to it. So I'm going to say string.erase. If I look up here, I need a position. So I'm going to start at position 0 because that's where my first name starts. The length in this case is equal to location +1 because I want to delete that blank space, not just Brad, but the blank space as well. So you can see the location that gets returned is 4, but we actually want to delete 5 characters, the 4 that are in Brad plus the space. So it's location +1.